Welcome back. This video will be looking at 11.3, so dealing with inverse of matrices. So let's just motivate this. We know that if you have any real number, we can multiply any real number by 1 to give us 1, right? To give us that real number. And if you multiply a real number by its inverse, it's going to give us what? It's going to give us 1. So if you have a real number, you multiply it by its inverse, right? What do we have? We have 1. So similarly, in the case of matrix, we have matrices. We want to find the inverse of matrix. If you want to find the inverse of a matrix, you need to know what we mean by an identity matrix. So an identity matrix is simply a matrix of n by n. So for example, this is In, is a matrix in which the main diagonals all contain the entry 1, while every other element is going to be 0. So for example, if you have I2 means 1, 1. It's just a 2 by 2 with 1s in the diagonal, main diagonal. This is I3. It has 1s in the main diagonal. And this is I4, 1s in the main diagonal. So you see that if you multiply a matrix A by In, it's still going to be matrix A. And also if you multiply In, which is an identity matrix, by a matrix B, it's still going to be a matrix B. So this is, don't forget, we know that if you have AB, it's not always the same thing as BA, right? Yeah, but if you are dealing with an identity matrix, it's okay. So for example, if I have A times In, it's going to be what? It's going to be the same thing as In times A. This is good. So the identity matrix commutes with any matrix, right? Non-zero matrix. So let's talk about inverse. Let's talk, okay, this is just to show if you multiply this is, so for example, this is I, and this is another matrix, you get the same matrix back, right? Okay. So now let's discuss about inverse. This inverse is simply when we are talking about what? N by n. So if you want to find the inverse of n by n, how do you do that? You see that what? If you have A multiplied by A inverse is the same thing as what? A inverse multiplied by A, and is the same thing as the identity matrix. So just like I said, if you have A multiplied by A inverse, remember is equals to 1. So in the same way, if you are dealing with matrix, A multiplied by A inverse is the same thing as the identity matrix. Also, A inverse multiplied by A is still the same thing as the identity matrix. So you can see that the inverse also commutes with any matrix. So if you have a matrix A, if the inverse exists, you will see that A inverse, A times A inverse is the same thing as A inverse times A, and this is all equals to the identity matrix. So for example, if you look at this matrix now, this is matrix A and this is matrix B. So if you want to check whether they are inverses of each other, all you need to do is to find the product. So this is A times B, and this is B times A. If both of them, A times B, you can see now you have an identity, and B times A is also giving us an identity matrix. So it means that this is I2, this is also I2. So what do we have? We have that A times B is the same thing as B times A, and it's the same thing as what? I2. So for this to happen, it means that B has to be the inverse of A. All right. So let's just delve into finding the inverse of a 2 by 2 matrix. If you have a 2 by 2 matrix, this is just A, B, C, D, right? How do you find A inverse? A inverse is simply 1 over AD minus BC. Then here you have just interchange this main diagonal here, and then you negate the. So now, is it always possible to find the inverse of a matrix? Sometimes it's not possible, so it depends on the determinant. So as you can see, what is AD minus BC? This just represent the determinant. So if the determinant is equals to 0, you see that there will be no inverse. So let me just explain this. So matrice that has no inverse, okay, are called what? Singular matrix. In other words, the determinant is equals to 0. So, okay, let me just put it this way. If you have the determinant, if the determinant of A, of any matrix, is equals to 0, this means that the inverse does not exist, right? It's also the same thing as saying that the matrix is what? Is singular. So anytime you hear a singular matrix, we are simply referring to a matrix where the determinant is 0. In other words, the inverse does not exist. But if the determinant, I'm just using A now, A represent any n by n. This applies to any n by n, not just 2 by 2. If determinant of A is not 0, then you have that the inverse will what? Exist. Then we can say the matrix is non-singular. So these are two terminologies, very important: singular and non-singular matrix. All right. So now let's see, how do we find 2 by 2 matrix? Let's just go to this already solved. For 2 by 2 matrix, let's just take these examples here. Now, if you look at this one, example 5 here. Example 5, we want to see. So find the inverse of the matrix, and for what values of x, if any, does the matrix have no inverse? So here, this one, we can call it matrix A. It's okay. We can say, okay, A inverse by formula is just going to be 7 times 2 minus 4 times 3. Then you just interchange. This one will be 2. Here will be minus 4, minus 3, and 7. And now this is just going to be, this is 14. So this is 1 over 2. And this is 2 minus 3 and 7. So A inverse, you can take the 2 inside. So this is just 1 minus 2 minus 3 over 2 and 7 over 2. Now, the first thing you want to know is you can check, is that what you see the determinant of A. What is the determinant of A? The determinant, even before you find the inverse, you should do that first. So here you can start by looking for the determinant of A. which is nothing but 7 minus this, which is just going to be 1. So we see that the determinant of A is not 0. So which means that A is what? Is non-singular matrix. So A is non-singular matrix, then you can go ahead and find the what? The inverse. Okay. So, but in this second, in the example B, you see that what? They have what? They have variables. So the first thing you can check is you can check the determinant. The determinant is just going to be 2x squared minus x squared, right? Because it's going to be 2 times x squared minus x times x. And this is going to be 2x squared minus x squared. So this is just x squared. So this is determinant. So you can see that the determinant is not equals to 0 if x is not equals to what? 0. So it means that what? A is what? A is singular. Let me just add this one here. So you can see A is non-singular for x not equals to 0, but A is what? Singular if x equals to what? 0. All right. But now we can, based on this one, we can find this one here. So A inverse is going to be 1 over 2x squared minus x squared. Then here will be x squared minus x, and here is going to be 2, right? So A inverse is just going to be 1 over x squared into x squared 2. But remember, we said x is not equals to 0, so we can just take it inside. So this is just going to be 1 minus, let's say 1 over x. And this and this is going to be minus 1 over x cubed. And down this is going to be 2 over what? Yes, so this is not going to be that way, sorry. It's just going to be minus 1 over x as well. Okay, and this is going to be 2 over x. So this is A inverse. But mind you, x is not equals to 0. So for C also, we can first of all look for determinant of A. We can call this to be A. Determinant of A, you can see is just going to be this times EX, then plus E2X times E2X, right? And this is just going to be e to the power 4x plus, this is also e to the power 4x. So what we have is just e to the power 4x. And you know that this can never be what? 0 for any real x. So determinant of A is not equals to 0 for any x inside real number. So it simply means that A is what? Is non-singular matrix. Now, since it's non-singular, we can easily find the what? The inverse, which is just, is going to be 1 over the determinant, which is already this one. Then here you will have what? You have, so here now we have to interchange this. This is going to be e to the power 3x. And this is going to be e2x to be minus And this will be EX. So it means the A inverse is, now we can take this inside. This will just be e to the power 3x for EX. And this will be e to x over 2 e to the power 4x, which we can easily simplify. And here also will be minus 2ex to the power 2ex to minus here. And this is this. So we can leave this as our inverse, or we can simplify. And this will be 1 over 2 e to the power, this is going to be minus x, right? And this also will be half e to the power minus 2x. This will be minus half e to the power minus 2x. And here will just be e to, I think it's half e to the power minus 3x. So this is A inverse. Then let's see what is D. Now D is what? D is a 3 by 3 matrix. Now, so let's talk about how do you find the inverse of a 3 by 3 matrix. Let's go up a little. Now to find, we have an example here. To find an inverse of a 3 by 3 matrix, all you need to do is that you augment the matrix. So if you have a matrix A, all you need to do is to, if you have a matrix A, all you need to do is to augment this matrix with an identity matrix of the same order. For example, if this is 3 by 3, right, we'll augment the matrix with this one. So this is now, this is your A, you augment it with the identity matrix I3. Then we will use row operation and to convert the matrix to I3, then whatever is remaining on the right hand side is our A inverse. So as you can see in this example, this is the matrix. You augment it with what? With 1, 0, 0, which is I3. Then we use row operations. So at the end of it all, after using the row operation, we arrive at this, you arrive at this one here. So you see now this becomes the I3. So whatever you have, this one now becomes the A inverse. That's okay? All right, so let's use the same idea to answer the, I think, question D, right? This one. So this is our A. We will just take this this one, which is 1, 3, 2, 0, 2, 2, minus 2, minus 1, 0. we augment it with 1, 0, 0, 0, 1, 0, 0, 0, 1. So now we need to perform row operations. So how do we do row operations? We know what it is. Here is already 1, so this has to go to 0, but you see this one is already 0. So we just need to take this one to 0. This has to go to 0 now. It has to go to 0. So we will have we'll have 2R1 plus what? Plus R3. And this is going to be 1, 3, 2, 1, 0, 0. And here is 0, 2, 2, 0, 1, 0. And here is 0, 0. No, this is not going to be 0. Because you have minus 2. Minus 2 times this is going to be, no, just 2 times this plus this. So here we'll have 2 times 3, which is 6, minus 1. So here it's going to be 5. 2 times 2, 4, plus 0. Here will be 4. 2 times 1, 2 times 1 is 2, plus 0 is 2. 2 times 0 is 0, plus 0 is still 0. 2 times 0 plus 1 is still 2. All right. So the next is this one has to go to 1. And we can do that by saying half R2. We do have R2. We will have 1, 3, 2, 1, 0, 0. And this is 0, 1, 1, 0, half, 0. And here will remain as 0, 5, 4, 2, 0, 2. So the next step will be to convert this to 0 and this also to 0. So what we can do is we can just add, remember this one to go. So this is going to be minus 3R2 plus R1. And also minus 5R2 plus R3. In that case, this will still remain 0, 1, 1. And this is 0, half, 0. Okay. Now, what we can do here is what? We can perform the operation minus 3. This is still going to be 1. This will be 0. Minus 3 plus 2 is minus 1. Minus 0. This is still 1. This one will give us minus 3 over 2 plus 0, minus 3 over 2. And this is 0, and this is still 0. Then 5, this will be 0, this is 0, and minus 5 plus 1 is minus 1, 0 is still 2, minus 5 over 2, and this is still 2. So the next will be to make this one to be 1. This has to go to 1. So we can just multiply this by 1. So I have minus R3. So this remains as 1, 0, minus 1, 1 minus 3 over 2, 0. So here we're still 0, 0, no, 0, 1. 1, 0, 0, 1, 0, half, 0. So this is 0, 0, 1. This is minus 2. This is 5 over 2. And this is minus 2. So the next thing, it will be to convert this to 0 and this to 0. So we can also do that still same row using row operations. So how can we achieve that? So for this to go to 0, it will just be, we can use the operation R3 plus R1. And what? Minus R3 plus R2. So this will still remain as 0, 1, 1. And this is 0, this is half, this is 0. Now here, this will be 1, 0, 0. And this is minus 1. And then here we'll have minus 3. So this will just be 1. And this is minus 2. Then here will be 0 minus R3 plus R2. This is still be okay. This will still be, yeah, okay. So let's see what we're doing actually. So wanted to take this to 0. So it's R3 plus R1. R3 plus R1. So let's replace this one first. Let's remove this. Because our pivot in this case is R3. So this will not change. This is 0, 1. This is minus 2, 5 over 2, and minus this. So let's do this all over again. Okay. So R3 plus R1, R3 plus R1 is going to be 1, 0, 0, then minus 2 plus 1. So this is going to be minus 1. Because it's minus R3. And we're just adding, so this is minus 1. Then we have 5, this and this. This is just going to be 1. And this is minus 2. Okay, then this one should be in the position of minus 3 plus R2. So this is still 0. This is still 1. So this is going to be 0. Then you have minus of this, which is 2 plus 0. This is 2. So minus 5 over 2, then plus 1 over 2. So we'll have -2. Then here also you have minus of this, which is 2, plus 0. So this is 2. Okay, so if every operation is correct, then you see now this becomes your I3. So whatever remains here should be your what becomes our inverse. So in this case, the inverse of A, so we're saying A means that we're calling this matrix also to be A. You can call it anything. So the inverse of A is -1, 1, -2, 2, -2, 2, -2, 5/2, and this one. Okay. All right. So I think there's something missing here. This inverse is not. How can you check? You can multiply this and A to see if it will give us I. But here I think there is something here. At this point where we said we applied to R1 plus R3. So it means this is going to be 2 R1. So this is 2 times 0 plus 1. So here is still going to be 1, right? Still going to be 1. So when we divide it by 2 in this place, so here will still remain 1. Okay. Then now we apply, we change this to 1. Okay. So we want to take this to 0. So trying to take this to 0, here is 1. So we have -5R2 plus R3. So -5 times this is 0, -5 times 1 plus this is 0, -5 times this, -5 plus 1 is -1, -5 times 0 plus 2, -5 times -half, so we have -5 times 0, which is still 0 plus 1. So here still remains 1. Yeah. All right. Then we did minus R3. So this is 0, 0, 1, -2. So here should be -1. -1. Okay. Then the next thing we did was to convert this to 0. So we had R1 plus R3, which is this plus this. This plus this is 0. This plus this is 0. So what we're going to have here, it's -1 plus 0. And this is going to be -1. -1. Okay. And then we also did minus R3 plus R2. So we have minus plus this, and this is 0. And this is 2. This is this, so it will be -1. So this is going to be 1. And this actually should mean as -1. Okay. So here it's not going to be 2. This is -1, 1, and -1. Oh. So I think the inverse is correct now, and you can confirm that by trying to multiply it with what? With A. You should get I3. So this is how to check. You can check A inverse times A. This should give you I3. All right, to answer the E question. So for this one, since you can see that some variables are involved and you want to find the whether the inverse exists or not. So all you need to do, it's better you find better you find the determinant. Yeah, you can find the determinant. If the determinant is 0, for values of x where the determinant is 0, it means there will be no inverse, right? And now how can you find the determinant? You can find the determinant either by using the Saros method, or you can just I remember, if you want to use the Saros method, you can go by this one. Okay, we know here is positive, here is negative, here is positive. So if you want to find the determinant here, so let's say determinant of A, this winner is just going to be 1. Then you close this, you close that. So you have minus E2x 0, 0, 2. Then minus EX. Then down this, you close this, you close this. So you will have EX 0, 0, 2. Then plus, now you have 0. Then you close this, you close this. So you take the determinant EX, E minus 2x, 0, 0. Right. So let's see it again. This is positive, this is negative, this is positive. So it's okay. So it means we're expanding along the first row. So you put 1 outside. Now you close the row, which is row 1 and column 1. So you'll be left with these 2 by 2 matrix. Now this position is minus, but EX is positive. So you have this. This take care of the minor. And this, it means you close the second row, you close the second column, first row. Yeah, so this and this close. So you are left with EX 0, 0, 2. And this is 0. So everything here becomes 0. Now this you can find, this is just minus 2E2X minus 0, right? Then minus, there is an EX here, but here you will have also EX minus 0. So this is minus 2EX 2X. And then this would become minus 2E2X as well. So I think everything becomes this one. Minus 4E2X. And you can see this one is always not equals to 0. So this is not equals to 0. And that means that what? This is not equals to 0 for all x, right? And what it simply means is that your matrix is invertible. We can find the inverse of this matrix. So we can find the inverse of this matrix. It simply means that A is non-singular. So how do you find the inverse of A in this case? You can find the inverse of K using the same what we did, the row operation. So let's see. This is 1 EX 0 EX E minus 2X 0, and this is 0 0 2. So you can augment it using 1 0 0 0 1 0 0 0 1. So this is our augmented matrix. So this is our A argument I3, right? And now this, we can also do it by row operation. So how do you perform the row operation? Here you can see this is 1 already. So all you need now is to take this to 0. And how can you take this to 0? Just take the negation. So it's going to be minus EX R what? R1 plus R2. Remember, this will still be 1. This will be EX. This will be 0. This is 1, 0, 0. So this is going to be 0. See that? And now you have minus EX. So if you do minus EX times this will give us minus what? To give us minus 2EX, right? So minus 2EX, then you add it to this one. Yeah, because we have minus EX. If you multiply minus EX and EX, so it's going to be minus E2X. So minus E2X, and there is another minus E2X here. So it's like minus 2E2X, right? Then here will still remain 0, whatever you do to it. So this is going to be, if you multiply minus EX and add it here, so this would be minus EX. So minus EX times 0 plus this will still remain as 1. Minus EX times 0 plus 0, this will still remain as 0. Okay. And this here already, we have 0 here, we have 0 here, and here is 2, here is 0, here is 0, here is 1. Okay. Now, which operation can we do? If you look at this, this is the first non-zero element. This is supposed to be 1. So we can divide. Yes, we can divide to make it 1. So because this is 1, we convert this to 0. Now 1 to make this 1. So we're going to do 1 over 2 E2X multiplied by what? By R2. This is 1. This will remain as EX. This will remain as 0. This is 1, 0, 0. Right. You divide this by 2. This is going to be 0. This is 1. This is 0. So you have minus EX over minus what? 2E2X. Minus and minus will go. Right. And so what is left here is just going to be 1 over 2. Then E, let's say minus X. So I think I have 1 over 2 E to power minus X here. And then here, when you divide, this also will become minus half E to power minus 2X. And here will still remain 0. Okay. But now here is still 0. So let's delete this. 0. And here we still have 2, 0, 0, 1. Okay. So what next? This is 1. This is 1. So we want this one to go to 0. And how can we do that? We can we can say minus EX R2, then we add it to R1. So this one remains 0, 1, 0, half e to the power minus x minus half e to the power minus 2x, 0. So if you do this, this will still be 1. This will be 0 now. This will still be what? 0. Right. So now you multiply this minus EX times this will go. So you just have half, right? But with a minus. So I think it's just minus half plus 1, which I think it's half. The same way, this times this minus will go. And you have e to the power minus x. And if you multiply this with 0, and this is still 0. Okay. Then here we still have 0, 0, 2, 0, 0, 1. So what is left is just to multiply row 3 by half. So this is 0, 0, 1. All right, so now we can divide this by half. So we have 1 over 2 R3. So this is 1, 0, 0, half e minus x, 0. And this is still 0, 1, 0, e minus x minus half e minus 2x, 0, 0, 0, 1, 0, 0, half. All right, so this is I think there should be a half here. Yes, and also here, because you have minus half e to the power 2x r2. So here when we do minus ex r2 plus r1, it's just going to be this time. So this half is still here. So this, when you add it here, so we have this. So it simply means that what? The inverse, you can see now this is I3. So this is our A inverse. So our A inverse now, it's this matrix, 1 over 2, half e to the power minus x, 0, half e to the power minus x, minus half e to the power minus 2x, 0, 0, 0, and half. All right. Yeah, so that is the correct inverse. All right, so before we move to something else, here are some properties that are very important. We said that the A inverse is always unique. So if you have a matrix A and you find the inverse will be only 1. So it means it's impossible for you to have a matrix that has 2 inverses. If you take the inverse of the inverse, it's just going to give you the same A. Now, this is very important. If you have A times B inverse, it's the same thing as B inverse times A inverse. And also this one is not true. This property does not hold. So if you have A plus B, you cannot distribute the inverse. It's not the same thing as this. Okay. So what you do in this case, it means you have to find your AB before you take the inverse. You cannot distribute the inverse. Okay, so now the last thing here is what we talk about solving matrix equation. And this is also very direct. If you want to solve a matrix equation, you have any equation, you can write it as what? As long as it's a linear system, you can write it as AX equals to B. So if you want to find the unknown, it's just you take the inverse of the matrix A and you multiply it by the right-hand side. So this is an example here already. Look at this one. This matrix, you can write this as what? We can write this as 2 minus 5, 3 minus 6, right? And then this we can just, this is our X, this is our Y, and this is going to be 15, 36, right? So in this case, this is our matrix A and this is our matrix X. So, but let me just leave it as this. So simply what it means that if I want to find this one, I just need to find the inverse of this one. I need to multiply both sides by the inverse. So it means XY is just going to be the inverse of this because this is what is happening. Let me just explain better here. Because if you consider this as your matrix A, and this is your matrix X, right? And you call the right-hand side your matrix B. So how can you get X? You know, you cannot divide by a matrix, right? But you can multiply both sides. So we can multiply both sides by A inverse times AX is equals to what? A inverse times B. So this A and A will cancel. A inverse and A will give you identity. So you just have X, which is equals to A inverse times what? B. But what is X? Don't forget, X is what? X and Y. It's a 2 by 1 matrix. Then what is A? A is this one, which is 2 minus 5, 3 minus 6. Then you just need to find the inverse, and then you multiply by B, which is 15 and 36. Okay, so that is it. And you will get your answer. So it's already solved here. It's already solved. That is what we have here. And now, so this is it. You just need to find the inverse of A. This is a 2 by 2 matrix. This is the inverse. Then this is from here to here is the inverse of A. Then you multiply by this. So you have this 30 and 9. So it means X is equals to 30 and Y is equals to 9. All right, so that is it for the first video. Then the next video, I will be looking at the old exam from 11.3. So thank you for watching.